Zombie apocalypse.
Okay, so welcome back. We're talking about Ethereum. Now we're talking about something called smart contracts. So we talked about how the Ethereum blockchain allows you to write code and have code executed across the network, across all the different nodes of the Ethereum network. Now we're going to get into some basic terminology and actually talk about some situations where that would make sense. Because, spoiler, it doesn't make sense for you to have every bit of code you ever want to write, every application in the history of the world should not be run synchronously across 10,000 computers. It just doesn't make sense. But first, let's define a smart contract. A smart contract is, put simply, is the code that you write that runs on the blockchain. But there's a little bit more to it. Why is it called smart contract?
So first, the definition of a contract. A contract is a voluntary agreement between two or more parties that is enforceable by law as a binding legal agreement. Now, in contrast, a smart contract is a contract, same definition, but it's enforced by computers. And you might be familiar with a smart contract or a type of smart contract already, and that would be a vending machine. So a vending machine has a simple contract, and that's if you put money into a vending machine and it's the right amount, the vending machine will give you something in return. It doesn't require an authority or a third party.
Yeah, there's no person there, there's no arbiter
to actually enforce that agreement. But people tend to interact with them, and most of the time they work.
Yeah.
Ethereum doesn't really have a situation where your Fritos get caught and don't actually come out of the vending machine. However, there are some subtleties in which these contracts won't behave in the way that you want them to. We're going to discuss that.
So returning to a more Ethereum-specific definition. Ethereum smart contracts are just the applications, the code that runs on the blockchain. And as we've already alluded to, this doesn't make sense for every single application in the history of the world. For example, a dating site, there are dating apps actually that do run on Ethereum, but personally, I don't know. But we believe that it doesn't really make sense, and it's sort of just capitalizing on some hype, some trends. But there are things that Ethereum smart contracts are good at. They're resistant to downtime. They're resistant to censorship. So just like anything where you have a centralized authority, if you have one server, if it goes down, your application would go down with it. If you have one server and the group in charge of it wants to censor something, they can do it.
Yeah.
Now, the last two, fraud and interference, we have an asterisk next to fraud because Ethereum smart contracts, when we say fraud...
You can't defraud a contract. However, you can write contracts that are fraudulent.
Yeah,
that
you can write sketchy
people.
code.
Yeah, sketchy code that can trick people into doing things that they shouldn't do.
Like in the real world.
You can
I've
write
heard
an
of
evil
many
contract,
stories of bad contracts or bad things that have happened when people sign their name and they didn't know what they're getting into. So to put that another way, code that runs on the Ethereum blockchain will run exactly as expected. So it's not Ethereum's problem if somebody doesn't know what they're getting into, if they don't understand the code, for example.
If somebody is deliberately deceitful in the writing of a contract, yes, you can trick people into participating and into interacting with malicious code that you've written. However, code that runs on the blockchain will run exactly as it has been written.
All right, so we've established the idea of a smart contract. It's just code that runs on the Ethereum network. And in general, it only makes sense if you care about downtime, you care about censorship or the lack of downtime, the lack of censorship, all that stuff. We'll talk about some examples again.
We'll talk about where that's good, and we'll talk about where that's not useful.
Yes, but again, we're taking a nuanced view. So not everything needs to run as a smart contract. So let's talk about something that would make sense.
A simple one.
So a simple example that we're going to talk about is something called a deed. So in the real world, what is a deed, Kevin?
So a deed is a representation of ownership of a property in this case. So if you were to buy the property at 123 Main Street, you would actually prove your ownership. You would actually be buying a deed to that property. And that's proving, hey, my name is on this deed. That means I am the owner of 123 Main Street.
And it's just a piece of paper.
Just a piece of paper.
Okay.
It's usually kept at the bank.
All right. So then what does making it a smart contract really do? What does that mean?
So suppose we didn't really trust our bank to hold on to that deed. What we could do is we could actually host that information, that piece of paper on the blockchain. And instead of having one copy at our bank, we could have the number of miners' copies of the deed, which means every single miner in the Ethereum network would instead hold a copy of our deed. And what that allows us to do is that allows us to really make our deed resistant to, for example, destruction. Once it's on the Ethereum blockchain, it's very, very, very unlikely that it will ever be destroyed. It doesn't look like any time in the near future that the entire Ethereum network will be shut down. Now, that's our resistance to interruption that we were describing on the previous page. So how would we use this deed? Suppose we wanted to transfer. So remember, this deed is just a contract. It's a piece of code that lives on the blockchain, and all that it has is two pieces of data. One, the address, and two, the owner. So represented here as the cyan circle around it. Suppose I wanted to give, or I wanted to sell this property to this person who's pictured here as what? It's like a blood orange color.
Yeah, you can just say blue and orange, Kevin. We don't have to go with these elaborate color descriptions.
I like the Pantones.
It looks like
Tangerine Tango or something.
Tequila sunrise off the coast of Cabo Orange.
Okay, we'll call it Cabo Sunset. So we've agreed that it's called the burnt street cone orange.
Okay, get on it. Get out of it, Kevin.
So suppose I want to transfer this deed to the person on the right, pictured here as burnt street cone Cabo Sunset orange.
The orange clip art.
Yeah, suppose if I want to transfer this deed, which in real life what I would do, I would go to the bank with that person, and then I would sign my name, and then we would transfer the deed to them. On the blockchain, what we would instead do is we would send a transaction to our contract. We'd send a transaction in the same way we sent a transaction to our Bitcoin miners. That transaction would say, I'm the owner of this deed, transfer it to this orange person. And that would mean that the deed would then update to that orange person. And the orange person would have their address. And from that point forward, they would be in control of that deed.
So when you say it updates, though, that means that it's updating across the network. Every miner is updating. Their computer is running code to update the value of the owner. What are we calling this? I guess we haven't said variable, but the place in memory that is storing the owner.
Yeah.
They're updating it across however many thousand miners there are at that moment to change from this owner to that owner.
Yeah. So in Bitcoin, we could only send Bitcoin. We could only send actual currency. Now in Ethereum, what we can do is we can send data. We can send a message to a contract and change data on the blockchain. That ledger is no longer limited to just holding, for example, the unit of Bitcoin. It can now hold information like the owner and the address for a deed.
Yeah. So the commands that are sent along are basically lines of code.
Yeah. Like Simple Turtle, it would be like you could send a turn left message.
Yes, or in this case, change owner message, or update, well, I guess that's it, just changing the owner.
It would just be change owner. And this contract would have been smart enough, would have been written in a way to only respond to an air quote change owner message if that change owner message is sent from the current owner. So for example, let's say I own it, and then Colt just is trying to mess with me and steal 123 Main Street. He couldn't send a change owner message to that contract. The contract would just ignore him. Colt, steal my 123 Main Street. So in the next video, we're going to give another example of a smart contract that's a little bit more useful than this, much more useful than old Simple Turtle, and a little bit more useful than our deed.
Okay, see you then.